we're going to take some notes on section 4 of chapter 3, linear functions. So please write all of this down in your notebook. If you need to pause the video, pause the video. I don't expect that you know and understand everything perfectly. You're just going to write down the notes, and then Monday during class, we're going to practice some of this. If you have questions, write the question down in the side of your notebook so you can ask me on Monday. So we're going to talk about linear functions. So what's a linear function? A linear function is a function whose points lie on a straight line. So you're writing all that down when you graph the function. But it does not need to go through the origin. That's only proportional. Proportional must go through the origin. But if it's linear, it doesn't need to be. So as you can see, my green graph and this green graph over here, those are linear. The orange ones, those are nonlinear. So if you want to just do some quick graphs to compare them to show that these over here are linear and these are nonlinear. Again, if you need to pause the notes, you can pause me. And then you can hit play when you're ready to move on. Okay, so this part of the lesson is how can we determine if a function is linear? Again, you're writing this all down in your notebook. If you need to pause me, pause me. Okay, so I can use a table to see if the ratios between the changes in variables in a table are the same. So kind of like we did with proportional. Proportional, though, is very specific. Linear is just as it form a line. So I can use a table to determine if the function is linear. I could graph the function to see if it makes a straight line. And if I graph it, I can tell if I have discrete data or continuous data. So discrete data means that I just have points. So discrete data is just points. In continuous data, I'm going to connect all the points. So for example, if I want to graph how many gallons of milk I can buy, that would be discrete because I can't buy a half of a gallon. Versus if how many gallons of gas did I use to drive from here to, say, San Francisco. I can use up parts of those gallons of gas. So those would be continuous points, whereas buying gallons of milk would be discrete. Don't worry if you don't get it right away. I'm going to give you some more examples, and then on Monday we'll practice some more of these. So write all of this down in your notebook, and pause me if you need to. Okay, so here's example 1. So how can we determine which function is linear? So remember we said there's one way you could look at the table. So I need you to copy all of this down. So now would be a great time to pause me. Then after you have the table copied, you can play. So if I go through and I look at the ratios of all of these, the difference in between my numbers on this one. So 2 to 3 is 1. 4 to 6 is 2. Then from 3 to 6 is 3. 6 to 12 is 6. So I'm looking at the differences between the two numbers. I'm not just taking 4 over 2. I'm looking at the difference between them. And then this one is 4 over 10. Do all of these form the same ratio? Well, this is 1 over 2. This is 1 over 2. I don't think that's 1 over 2. That's 2 over 5. So is this linear? I'm going to guess no. Okay. So now let's look at the other chart. We want to look at the differences. Okay, I just cleaned up my screen a little bit. So let's look at the differences over here. And so if I go from 4 to 5, that's 1. From 16 to 20, that's 4. 5 to 6 is 1. 20 to 24 is 4. 6 to 7 is 1. And 24 to 28 is 4. So yes, this one is linear because it's a constant rate. And this is non-linear. Okay, don't worry. Again, we're going to practice some more of these. If you don't get it right away, that's okay. It's just getting the notes down. If you need to pause me, go ahead and pause me. But if you're ready to move on, go ahead and move on. Okay, now you're going to try one. So go ahead and copy this down. So you're going to write down that you tried. Determine if the function is linear. And when it asks you to explain, you can kind of show the math to show if it's linear or not. So copy down the chart. You should see a text box on the right. You're just going to type in linear or nonlinear. And then, of course, I'll give you the answer, but not until you've given me an answer first. So type in your answer. Probably need to pause, do some calculations, write down some math. Don't just guess. Do some math in your notebook like we just did. And then write down your answer. Okay, so here's the answer. So yes, the ratios between the changes are the same. So if we compare 5 to 9, we get 4. Negative 12 to negative 13, we get a negative 1. Oh, goodness gracious, that makes it hard to see. So let's not do that. Okay, then here, 9 to 17 is 8. Negative 13 to 15 is negative 2. Okay, here we have 17 to 21 is 4. 15 to 16 is negative 1. Does this equal 4 over negative 1? You betcha. So yes, the ratios between the changes are the same. So yes, this is linear. Again, if you don't get it, that's okay. We're going to practice on Monday. Just write it down. If you have a question like, I don't understand why I'm using these numbers and I'm not just taking 12 over 5 and 13 over 9, go ahead and write those questions down. So remember, we're looking at the ratio of the changes in between our numbers to see if this is a linear function or not. Another method we can use, so we can use the tables, but we can also graph that data from the table. So earlier, remember I talked about discrete. So discrete data are for counting. So those must be whole numbers with no data in between. So I could count the number of cars, the number of people, the number of books, the number of points. So my example earlier was the numbers of gallons of milk I could buy. That's discrete data. Those are little data points versus, and they do not connect with a solid line. You don't connect those, you just leave the dots. Okay, so here's an example. It's still forming graphs, but I just don't connect the dots. Okay, because I can't have half of a person. And then I have, oopsie, it's kind of fast. Then I can have continuous data. So those are numbers that have a wide range and can have data between those numbers, like calories, temperature, distance. I could use my other example of using gallons of gas from my car, because I fill it with like 15 gallons or 12 gallons, I don't know. My Vespa only takes like 1.2. And I'm going to connect those with a solid line. Okay, so write down all these examples, maybe jot down a couple of graphs to show the differences. You'll probably need to pause me. And then when you're ready to move on, we're going to move on. Okay, copy all this down. Again, if you need to pause me, go ahead. You can pause me. Here, determine whether the data is discrete or continuous. We're going to make a table and a graph. So notice I made a table. Juice costs 2.19 per gallon. Okay, so let's first of all determine, is this discrete or continuous? Can I buy half a gallon of juice? I don't think so. So the data is discrete. Okay, now I want to graph it. So I'm going to, perhaps change the color of my pen. So this looks better. Using a ruler would be even better. So I'm going to graph. Here's my gallons. Over here is going to be my cost. So I can have 0, 0. I need to have counting numbers. I can't just throw down the numbers. So I am going to go 1, 2, 3, 4 for my gallons. I could continue it on 5. And then cost. Oh, these are awkward numbers, aren't they? So we're going to just kind of guesstimate. Let's see how many lines we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I can't really do double. So I guess we're just going to count by one. So that's $1, $2, 3, 4, 5, 6, 7, 8, and 9. So now I'm going to go over $1 and up to about $2.19. Put my dot. Go over 2, go up to 4.38, put a dot. Go over to 3, go up to 6.57. So go 6 halfway, a little bit above, and then go to 4 gallons, 8.76. Whoops, where'd that go? I said do that dot. Let's do that dot. 867. Have 4 gallons, Mrs. Miller. There. Not sure where that last one was. Let's get rid of that too. So we did 3 gallons. Oh, that should have been there. Oh, goodness gracious. Okay, 3 gallons is about here. 4 gallons is about here. Remember, this is discrete data. Do I want to connect the dots? No. Probably want to give my graph a title, though. Cost of juice. Okay, so go ahead and write this down. Copy it down the best you can. Remember, we're going to go over it on Monday. Please don't stress about it. Okay, so now you're going to try. So we have this function. The cost of going to the aquarium is $45 per ticket. So the cost is in dollars. T is adult tickets. Okay, to the Monterey Bay Aquarium. So first I want to make my table. I'll get you started on the table. So I kind of still want to do my input-output. So my input is my tickets, and my output is going to be my cost. Let's do a 0, 0. Let's do 2, 4, 6. So you figure those out. And then you're going to make a handy-dandy graph. So you need to figure out, what am I graphing? What's my title? Is this discrete or continuous data? Let you figure that one out. Then go ahead and graph it. Okay, so you can't really put this in the box on the right, but you can tell me if it's discrete or continuous data. And then I should be able to see a beautiful graph in your notebook on Monday. Okay, so pause me when you're ready. Go ahead and move on. Okay, I didn't give you an answer to that one because I want to see what your graph looks like, not what my graph looks like. Okay, so here we have continuous data. So Sammy earned $7 per hour. The function E equals 7H gives Sammy's total earnings are E, in dollars for the number of hours H she works. Use the equation to make an input-output table, which I did, and graph the function. So I made my input-output table. So remember, my input is over here, that's H. And my output is, what do I get out of it? So what does Sammy get out of all those hours of work? Okay, so here I made my input-output table. And then I'm going to do my graph. Okay, I'm going to say hours down here. I'm going to say Sammy's earnings over here. Okay, so Sammy worked up to 3 hours. So I have 1, 2, 3 hours. I could probably spread that out more. Okay, and my earnings are $7, $14, and $21. So let's see how many lines I have. 1, 2, 3, 4, 5, 6, 7. Ooh. Maybe I could count by $3 increments. What do you think? So this would be 3, 6, 9, 12, 15, 18, $21. Okay, so if Sammy doesn't work, she can't get no money. And then if she works 1 hour, she makes $7. That's a little bit up from there. And then if she works 2 hours, she gets a whopping $14, and if she works 3 hours, she gets $21. Okay, can Sammy work 2 hours and 15 minutes? You betcha. Can she work 0 hours? Yes, so we're going to connect that, and then we're going to make this graph, and we're going to put it into infinity and beyond because Sammy could work all those hours. Ooh, what did I forget on my last ones? I need to label this as X, and I need to label that Y, and I need to make my graphs go on to ever. So I need a title. I might call this Sammy's Money. Okay, so if you need to pause me, pause me. If you're ready to move on, go ahead and move on. Okay, the last you try. We know this is continuous data, so you're going to make a table. So you're going to make your input-output table for the function A. 4,000 minus 600 m gives the altitude. How high up in the air is my airplane? after M minutes, okay? So, looking at this, is my plane landing or taking off? Well, if minutes are 0, you know you're at 4,000 feet, so my plane must be landing. So you're going to make your input-output table. So remember, your input's your minutes, your output's your altitude. We could put in a 0. You can pick whatever numbers you want and then make a graph. So I want to see your graphs on Monday. Okay, make sure you label everything. Make sure you give it a title. So when you're ready, you can pause me. When you're ready to move on, this might be it. I don't know. We'll find out. Whew. Okay, that was it. So we'll do some homework in class on Monday looking at this material. Have a great weekend and be nice to Mrs. Clarkson.